Hello everyone, welcome back. So this is the result. I cached 100 frames and this is a preview. Pretty happy with the result. I think it's gonna look really cool with all the other blocks added. Maybe the turbulence is a bit too strong, but I think it's fine. I think maybe was a bit stronger gravity, maybe some more dissipation. I think less turbulence would be better here, especially that these are nice, but I think this is too much, so maybe less turbulence overall. But that's pretty much it. There's nothing complex about the debris setup, even without using any turbulence and just having some velocity in the source, you could get some really nice result. So the next thing I want to show you guys is a trick on how to make a more efficient or a more accurate bounding box. And as I said, it's gonna clip, like you can see it here, perfect example. See, that one is clipping, and that's because it's moving really fast, and even if the domain has updated, the sim didn't catch up to it. So the way we're gonna do that, we fix it, is by using a smoke solver. A SOP solver. So let's create a SOP solver. I'm gonna plug it into the fourth input. You know, this may look weird, but it actually works. Let's connect this here and let's dive inside. And what I want, let me copy this. I want to import that, the current bounding box. I want to keep that. Okay. And these nodes, if we go to, let's say, okay, so that frame, I'm going to pin the viewport. If I dive inside, I should have the density field. So the reason it's not importing the density field is because it's looking for something called geometry. The data type is called geometry. We need to type density here. So now we have the density field imported. And what I also need for this idea to work is the velocity. So I need the velocity field, and that's called vel. And I need them to be as VDB. So I'm going to use a VDB convert from convert VDB, and this is VDB now. Here it's a Houdini volume, this is VDB, and I want to vector merge all of them because the XYZ, we want a vector field. So that's a vector field now. You can see it here. And I'm going to scatter points onto the density field. So that's my points. I have 1,000 points. I'm going to use VDB advect points. And I want to move points to advect and then the velocity field. And I want to advect these points with the velocity field. Make sure it's set to vel. And I don't need that to be on. Yep. So if we compare the points before and after, so this is before and this is after, the points have moved. So if we have a debris source and its velocity is pushing it in different direction, we can use this advection method to offset the points enough to capture those details. And then I'm gonna merge this with my current domain. Maybe here it's not visible, but it will show up later. And I'm gonna do another bound node based on all of this. So this, I'm going to use an add node, delete geometry but keep points. And now I have all this. If we do a bound now, it should compensate for everything. I'm just going to add a bit more, just one in all axis. And now we have a much more accurate, it's gonna read the velocity field, we're gonna scatter some points based on our density, and then we're gonna advect them, so we shift them along their correct velocity vector, and that's gonna give us the padding that we want. And then we run another bound, and let me create a null output and call this out new bound. And let's copy this. Let's go up. And now here, I want to reference that. It's a SOP solver, so I'm not going to change that. The other option, the DOP, is actually would require a DOP node like these, but it's still in SOPs. This is a SOP solver. Okay, so that's what how we're going to do it. And let me unpin this. And that's it, should be it. And let's go up. And now if we hit play, we're not going to see any difference here, but this is, I guarantee to you, it's going to improve the source. And that's pretty much it. Let's set up the different sources now. So we have this this node, and I'm going to call this sim underscore cluster 0. And let's do like we did before. I'm going to copy, drag and drop this, and set to change the value. I'm going to copy this expression, and I'm going to go here, set it to Python, make sure there is no spaces, and that's out cluster or sim0. And I'm going to copy this. I'm going to change it to 1. Same thing. And here I'm going to change it to 1 as well. This is 2. And this is 3. That's it. I will just send this to and calculate them. And then we're going to have 4 different caches. Now I'm going to load in the caches. If I just find them. So this is the original sim I did. I used a different scale because I wanted to get, it's not going to affect anything, but it's just going to work better with the turbulence scale. I didn't want to add this complication because the final result that we made together is probably better than this. In fact, it's better from looking at this frame. And so these are the different clusters. I'm gonna control shift click on each one of them. So that's 0, 1, 2, and 3. And if we go to a different frame, that's our final sim. And that's pretty much it. That's how we handle large amount of data. We cluster the initial geometry, we separate it into blocks. It's also a great way to add, to do the VDB this way, to convert the geometry into VDBs, because having smaller domains of a group geometry is better than having one geometry with everything. And it's also much easier to batch this on the farms. If you have 4 different jobs, you can send them and each machine will take one job versus having one that is really slow. So this is the final result, and it's pretty much the same as what we did now. And I can tell you the trick is not in the Pyro solver. The trick is in getting the collision using the STFs and in creating the proper emitter using the various techniques that I showed. And that's pretty much it. Thank you guys for watching, and see you in a bit.